Зараз наша друга доповідь, другий спікер це В'ячеслав Леськів, Python-девелопер в нашій компанії в Levi9. І нам він розкаже про Data-Driven Objects in Python. Я зауважу, що доповідь В'ячеслава буде англійською мовою. IT-спеціалісти часто розмовляють на такому сленгу, в якому перемішані українські і англійські слова, і інколи, навіть коли ти повністю говориш англійською, твоя промова виглядає більш органічною і консистентною. Отже, В'ячеслав, тобі слово, будь ласка, починай.
Hey, I hope you can hear and see my presentation. And today I want to talk about data-driven objects in Python and what they are and how can you achieve them in Python. First, the agenda, what's data-oriented programming and DTOs, and then different types of things you will use in Python. And then in the end, we'll compare them in performance and what features they have and don't have. But first, let's start with what the hell is a DTO. DTO stands for a data transfer object. It's a design pattern for programming meant for defining fields without any logic. So it's basically just data packaging. Here you can see an example in Java, and because of the holy war that happened in the previous example, I need to put my 5 cents. I think in Python, there's good ways to do OOP, but most developers aren't learned to do OOP. In Java, you are basically forced to do a lot of it. And this is why I put an example in Java. Don't worry, it's a Python presentation, but you can already see that it wasn't started in Python, but it's quickly getting adopted. DTOs are useful in systems that are mostly described as microservices. So you have many nodes, but one distributed system. For example, my current work project really fits into this description. We need to have sort of the same data for a lot of different projects. So we don't want to include logic in one project and then have to rewrite it in another. We just want to define like, okay, let's have these fields here and these there. And without any logic, just, hey, I want you to have this data and this data. It's helpful when you need to group values and structures which are just ad hoc. You're passing data around, but you don't want to do anything with them. You're just, hey, you expect this data, please get it correctly. And for people, it's hard to examine like, okay, why is this actually useful? Why would you use it? And I have sort of a weird example, but I think it works well. This is OpenAPI. You will actually never write this code. It's generated by the frameworks we use every day. So for example, AWS, it doesn't know how to read Python code, how to read your new trendy library. This library creates this OpenAPI schema, which then Amazon reads through. And okay, it creates that endpoint, and it creates that endpoint, and it creates that endpoint. And you can see here that there's different definitions of objects with some fields are required, with some fields having inheritance and stuff like that. So we define objects in Python, but in the end, they look like this schema, which is very nicely described, and it's pretty universal. So what are the ways of using this DTO in Python? Your first thought might be, okay, let's use a class. Class is known by everyone. It's basically the first thing you do in Python besides print. But here you can kind of see, like, you'll run into issues very quickly. For example, let's have a basic class called ticket with a name and a description. Here you can already see that you repeat some stuff 3 times, but let's ignore it for now. Let's just continue. I'm debugging something, there's happened some error and something fails. Okay, let me put it into the console, and you can see that, okay, it's a ticket object, that's some reference that you cannot explain. This isn't useful, but thankfully Python has a solution, a wrapper class. So you write it out and everything is good, it works well. But here you can already see, like, hey, we wrote some code, it's not that good, but hey, let's leave it. Then you want to compare your class with equals via some field. Okay, Python class doesn't have that by default, let's write it out again. Not ideal, but hey, it improves speed a little bit and it adds some functionality to your class. Maybe let's add not equals as well. It helps, again, with speed, and it adds some functionality. And then, for example, you want your class to be put into a dictionary. That means it needs to be hashable. So, okay, let's write out a hash as well. Useful. And then let's complete this entire thing with less than equal, greater than, and greater than equal. This code is already becoming insanely big. As you can see, like I can barely fit it on my presentation. And yes, technically, you can only use you can only define one of them and import a library from functors, which will write everything else by yourself. But that's also not ideal. So hey, let's maybe not do this. And then, for example, imagine your product owner comes to you and says, "Okay, Slavik, let's add another field." And then you look at your code and you're like, "Okay, I need to add some data here, some data here, some data here, some data here." You're basically rewriting your class every time you need to add a field, which might happen a lot in your system. But we live in the future. Python 2 is dead, and we're living in the Python 3 areas. And there was a solution come up with this, which is really nice. And it's use Chrome for everything. Google Chrome wins, and yeah, please use it. That was a joke. We have this thing called Dataclass, which came in, I believe, in Python 3.7 and does a lot of magic stuff, so you can write your code better. For example, here we define another ticket called class in the same way we did before, but here we don't write a text a few times. We just write it out once. And here's the magic. If you print it out, you can already see it doesn't do the same stuff as class. It's already printed out how you want it. Magic. This magic you can actually see if you inspect these functions. And you can see that Python under the hood adds these Dunder methods for you. They are implemented correctly, and they will update every time you add some new field, you delete some field. It's all automatic. And you can obviously control it. So for example, if for my data class I add a frozen true and an order true, I get a bunch of new methods that evaluate of these features. For example, hashing greater than, less than, equal. And I don't need to write any of this out. I just need to add some variables, and it works greatly. Also, the data classes has frozen instances. So you cannot change the name of the instance after you assign it. It's a great thing, and again, it shows how data classes are really being very nicely thought of with every feature you might need. It's loading very slowly. Also, if you know Python and you come from another language, you might face an issue with lists. I know my brother had this issue in his production, and it absolutely shocked him. How can this matter? This is where experienced Python developers, they know about this already, and like your first question might be, okay, how does it handle lists? Data class has you covered. We have a default factory that creates list how it is meant to be. It doesn't break at all. Everything you can think of was already thought of. And obviously, you might not want to include some fields in your response, in your prints. You can disable these features very easily. Just have wrapper equals false or hash equals false. And you can do this with basically every field in data class. It's very customizable, and it does a lot of magic for you. It's basically like the perfect description of Python I can give to you. But it wouldn't be a Python without a few other notable things or similar stuff. For example, attrs. A data class was actually built on top of attrs, as it inherited a lot of stuff from it, which you can see here. It's basically the same idea. You create a class, you do the same text as they are, but here there's some more verbosity because data class was built by Python engineers and it's built into the system, so it has some greater advantages for the compiler. But attrs has two features which data class does not have. One of them is converter. Converter is when you want to take one type of class or data type and you want it to convert it to another. You can actually do it automatically, which Dataclass cannot do right now. And you need to define it by adding to certain fields manually. Also, Athers has validators. Validators is when you really want to make sure that the field you're receiving will be absolutely correct. The error here isn't perfect. There are libraries that do way better errors, but hey, it's still something. It's mostly readable, I'll say. If you've kind of new to Python or new to programming, your first idea might be, okay, why not just use a tuple? Tuples are really fast, they're really easy to write out, and they're easy to understand, so you don't need to write a lot of them. But quickly, you come up with the reason that, hey, this isn't good. For example, let's write a basic tuple, no imports, no anything, and you can see there's no typing support. You get items in a very unsafe manner, and you don't have any good prints or anything like that. Yes, it's fast, which you will see later on, but if you work in a production system, this will quickly overwhelm you and your code will become unreadable. But there's some better solutions that came up. First is name tuple lowercase. There's another one which makes people confused. And this one's way better than normal tuple, but still not perfect. It has a kind of word structure to create a class. You can see it in a ticket plus text description. But it doesn't have typing support. But as a plus, you get in variables by the name, which is nice. It's better than square bracket 0, which can break all the time. And I think the best solution, and honestly one of my favorite things, is name tuple uppercase. It's very similar to Dataclass. You just import name tuple, and it has typing support, which is really nice. And again, you can get variables by their name instead of square brackets. It's actually really useful because, first of all, it's speedy. It's still readable. But yeah, it doesn't have converters. It doesn't have validators. It's still quite raw. For some cases, this is the perfect choice. Another probable choice that you might make is dictionary. Dictionary is also the same level as tuple, where it has some advantages in for the Python compiler with speed and performance, but it's still not the best. For example, here we can see that, again, we don't have any typing support. Our class is defined very weirdly. There's no support, and you get values in a very unsafe manner by square brackets and typing out the name. This isn't the best, and I highly recommend to not repeat it. There's a better solution called type-ticked uppercase, which does the same thing as other solutions, where you import it, you write a class, you inherit from it, and then you create your dictionary. This is where I think it's not useful because you still create the dictionary in the same way. You just do a type hint for that class, and that's it. You still get items in a very unsafe manner. And you don't get a speed performance. It's still a dictionary under the hood. Why not just use a tuple or something that has more features and is more well built? And a special guest of our presentation is Pydantic. Pydantic kind of grew up in popularity. So before 2019, the go-to parsing library in Python was Marshmallow. And it actually is, Marshmallow is used in a lot of other languages as well. But after the rise of FastAPI, Pydantic kind of became this king of everything. But it's obviously not perfect. It's the same idea as Dataclass. You import some model, you inherit it in a class, you write out some stuff, and you get the same idea, like, hey, you can get values by their name in a safe manner, you can, and it all prints out finally. And one thing I like about Pydantic, it's very strict. So for example, here, it really wants me to, hey, say the text is Slavic and description is Greek description. It doesn't want to do it automatically for you. It's like, hey, please define it how you want it. And I really like this because it's strict, it makes you work more. Probably the best feature of Pydantic is that it has built-in validators, and that you only need to define via their types in Python. So for example, in address, if you remember, you needed to write out some code, write out, hey, please use this validator here. You can just use built-in typing support from Python, and it just works. You can see that the error is quite readable. Hey, you didn't put the correct value, dummy. Please do it correctly. But also, it does some stuff that I personally dislike. For example, it actually does conversion. So, for example, if you put an integer into a string, Pydantic will still convert it because, hey, it's basically the same thing. I really don't like this feature, and I really don't understand why it was built in. And Pydantic is very strict in our cases, but it's there, and it kind of helps some developers. But there's actually breaking news as of Monday this week. There's been a lot of discussion and a lot of talks about Pydantic 2.0, and the plans became official this week. And the basic idea of it is going to be way faster and add or remove some features that were missing. So, for example, you will finally have an option to have very strict typing support. So, for example, on the previous slide, your data could silently convert. In Pydantic 2.0, it will not be able to convert. This is, I would highly recommend to read it. As you can see, it's a 25-minute read, so there's a lot of stuff there. But yeah, get ready for it. And performance and feature matrix. In Python, performance does not really matter that much. If you're looking for performance, there are languages like C++, C, even Java that do it slightly better. You're writing Python for the pure usability and ease of use. But I think performance is still useful because you can see how they're implemented inside, and it's still important in some cases. So let's show it. As you can see, Pydantic doesn't really look that good. But I want to point out that the time is in nanoseconds. So it's really, really fast, like really, really fast. Here you can see three variables, create, getAttr, and setAttr. Create is when you create a new instance of a class and use it. GetAttr when you get a variable, setAttr when you set a variable. You can see that pretty much everything is quite lower than Pydantic, so let's just remove Pydantic from the picture and let's look at the other solutions. As you can see, the fastest one is Tuple. Tuple has a lot of advantages. It's built into Python, so it just screams for everything. But it's not really readable. The same with dictionary. It's also fast, but again, it's not very readable. You'd rather go for a solution that has slightly less speed, but is way more readable. And why would you go that? Like, hey, by this graph, I only want speed, so I'll never use Pydantic. Let's say you have a call to database that takes about less than 1 second, like a half second. You can see that this call to database just dwarfs everything. Pydantic is barely even shown, and the rest is just silent. So the bottleneck in your system most of the time won't be these libraries. It will be the databases process or something like that. But let's get back to create. Create for Pydantic is really, really big because it does a lot of parsing automatically and for you. That's why the Pydantic 2.0 is one of the main goals was, hey, let's improve this speed because this looks ridiculous, and it does. But let's go back to Earth again, and you can see that, hey, it's pretty normal. Tuple and dict have some advantages, but everything else is pretty fine. Get attribute. Well, create you might not call a lot of times in your system. get attribute might get called way more, like way more. So the performance here is slightly more important than create, but you can see that everything here is pretty well defined. It's all in line. Pydantic kind of stands out, but it's not as jarring as the other example. And then there's set attribute, where Pydantic again goes bye-bye performance and just screams away at everyone. So let's lower it to the ground and see that, hey, everything else is the same, but you might be wondering, hey, why does tuple not have set attribute? Well, tuples, they cannot. So for the tuple, you actually pay the create cost, not the set attribute cost. That's why it's 0. So you need to remember that, hey, that in tuples, when you create an object, it will be way more expensive, but it's later down the line, it's faster. And then memory usage. Everything here is kind of defines itself. Tuples, they use less memory because they're a defined list, defined objects, and then we have something called slots for plain class and attribute class that also match this memory usage. And everything else kind of raises to the top because it's based on dictionary or it's just a class, but nothing out of the ordinary. And a feature matrix where you can see every example here. My suggestion and my favorite thing to use is nametuple. Nametuple is really fast, it's quite readable, and it's useful for small solutions like coding tutorials, like code wars, stuff like that. It's really fast for that, it's really readable. If you want a built-in solution into Python, which does basically everything, Dataclass is your way. It's supported by basically every library, and it has basically all the features. But if you want, okay, I want every single feature, I don't want any compromises, and I don't care that I need to install it, then I think Pydantic is the way. Yes, it's slower than the other solutions, but it really won't affect you because of the improvements to the code you will have. And in the end, I want to say this. These solutions, they look kind of similar, they look kind of the same, but under the hood, there's a lot of differences between, hey, what are the features, how it will be used, how it will be created. So first you need to examine what's your issue, what's your problem, and then be like, hey, okay, this is the best solution because it has X and Y, or this solution is bad because we need a Z, something like that. And yeah, questions, that was everything.
Thank you, ячеслав. Interesting story and nice comparison of various implementation of these data objects. So thank you. And the questions, let me check 1 second. Якщо у вас є можливість використовувати сторонні бібліотеки, так. Ну добре, я закінчу з цим питанням, бо там ще є багато. Якщо у вас є можливість використовувати сторонні бібліотеки, то Dataclass вам нічого не дадуть. Це такий мінімальний спосіб зробити своє життя легшим, живучи в std-lib Python. Хоча, може, це було відповідь на інше запитання в чат. Ну, якщо є якийсь комент на це запитання.
Ну, Dataclass, тобто, якщо тобі не потрібен парсинг або валідація, тобто це найкращий solution, тобі не треба нічого скачувати. І дуже багато бібліотек підтримують його. Тобто майже всі бібліотеки, вони як базу беруть Dataclass. Тому що це зробили люди з Python, і там все нормально.
Good. Цікаво почути про різницю між wrapper and str. Я так розумію, string.
Yeah. Answer in English, sorry. The wrapper is mostly meant for console log or something for programmers. str is mostly meant for human readable stuff. So, for example, in str, you wouldn't put passwords or something like that, while in wrapper, you might put something way more secretive in there. It's just a difference between, hey, one's for users, one's for programmers, or debugging the system itself.
Добре. Ще одне запитання. Can we add some methods to the data class?
What kind of methods? So you can data class. I believe, yeah, you can add methods. I'm not sure why would you add them, because data class point is just you store data and you don't have any logic in them. So for example, in Pydantic, you can write out validators in that class, but they mostly just do validation. They don't do any business logic. The idea of this object is we just store data in the correct type. The business logic is handled by some other class or some other instance.
Окей. Наступне, що робить функція utter.ib, якщо я не помилився. utter.ib чи lb.
Well, others. It's related to others. It's if you look at data class and others, iter.ib is just a way for the otter library to know, hey, this is an object and this is its type. It's not required in data class because they do sort of magic in the compiler where you get this value anyway. It's one of the benefits of data class being built into Python, as opposed to having a library where they need to write it out because they don't have the advantages of that.
Угу. Дякую. І робити валідацію в класі замість серіалайзера чи будь-якої в'юхи, куди дейта прилітає. Може, це частина якогось діалогу в чаті, я не знаю. Прокоментуй.
Yeah, I'm not sure how to answer that.
Добре. Тому що, знову ж таки, там був діалог між деякими запитаннями в чаті, і може це запитання вирвано з контексту. Добре, зараз я ще подивлюсь. У Python нема строгої типізації. Який спосіб є найкращим, щоб переконатися, що дані в DTO правильні? Наприклад, в DTO мають бути об'єкти з Django, ORM. DTO приймає деякий клас configurator.
It's when Pydantic, these validators, they do this stuff. So Python doesn't have strong validation, but these libraries, specific ones, some have it, some don't. They implement it for you. That's why you might see a speed penalty when you do it, because it's not built, but the libraries basically do the validation for you. So you do have strong type, and it's not on the side of Python, it's on the side of the library.
Угу. Зрозуміло, добре. What do you mean by safe and safe call for the fields properties? For example, why getting dictionary dict value isn't safe?
Because if that value isn't there, there's going to be an error. So if you want that value to be none, you have to do get and stuff like that. It's really unsafe, and libraries like Pydantic, when you do these sort of getting of attributes, they do a lot of stuff to make your exceptions easier and more readable. Because if you get an attribute error in your code, you will need to go into your code, debug, test this on the same input. In Pydantic, you just see the error correctly and hey, this value isn't there.
Дякую. Does low performance really affect development in case of Pydantic?
No. I think Pydantic, with its features and its capability, does a lot more good than harm. If you need performance that much, then I think Python wasn't the right choice to begin with. But Pydantic's the main bottleneck of your system will be database calls. Those take a while, and some other processes. Pydantic won't be the main issue in your code.
Угу. Дякую. Чи може бути поле дата класу інший дата клас, і чи це є хороша практика?
Yeah, it's about inheritance. I think it's basically about inheritance. You can use it in some libraries, but it's highly recommended to not do it. It can become messy, and for example, my my work project right now, it has a lot of inheritance, but it's really careful, and you need to realize that some issues will pop up. I don't know if you can put a data class as a field. Probably not, but you can inherit from one and do stuff that way. I don't recommend it though.
Дякую. Далі пішли класні запитання, мені подобається. Яка взагалі різниця між дата-класами і name tuple?
Data class is built on top of dictionary, basically. It has a lot more features than type-dict, but it's still under the hood. It's built on top of dictionary. While name tuple is built on top of tuple. So everything that relates to tuple relates to name tuple. Everything that relates to dictionary relates to the data class.
Угу. Дякую. Чому Pydantic використовують найчастіше у FastAPI, але не у Flask чи Django, наприклад?
In FastAPI, from the beginning, it was meant as firstly async system, secondly as a type system. So the creator of a triangle at that point picked Pydantic. Don't know the reasons, don't know why. And from that point, FastAPI was built mainly on Pydantic with the usage of Pydantic. That was its initial goal, but recently FastAPI added support for data classes and some other stuff, But if you use FastAPI, it is basically assumed you're using Pydantic under the hood. Why is that the reason? Not sure. Maybe he liked the library, so yeah.
Добре, тепер ще запитаннячко таке про перформанс. Вячеслав, when saying that overhead of a database call dwarfs the cost of even Pydantic solution, did you imply that we normally extract just a single record from the database? Is it really the case?
Well, even if you extract a single instance, you need to connect to the database, you need to do some SQL, you need to disconnect from the database. It all takes time, and the examples in Pydantic are measured in nanoseconds. The connection to the database will be more than Pydantic even for one field. So it's this performance might come in handy if you already have millions of records extracted to Python and you need to go through them. Maybe Pydantic will not be the best solution, but I think it's still the easiest to write out.
Добре. І останнє запитання, коротке, з огляду на час, це що використовуєш у себе на проєктах? Який підхід?
Our project uses FastAPI, so we use Dataclass under the hood. We use not Dataclass. We use Pydantic under the hood. Sorry, Pydantic with a lot of inheritance, a lot of Pydantic validators, which is a really interesting topic. I highly recommend to see because they're interesting. But for us under the hood, it's Pydantic. We like it. It's performant enough. We don't really have any issues.
Ну, і я так розумію, всі з нетерпінням чекають другої версії Pydantic, щоб з ним погратися, може він буде ще кращим.
From what I saw, from what I read, because I read it in 5 minutes, I just saw it and was like, okay, let's skim through it. I really like that you can disable automatic type conversion, so you need to define it very strictly. I hated that, and I'm really happy it's finally going to be a feature. But I think it's for Python developers, it's scary to see something change a version after Python 2, but I think it's a good thing, and it will fix a lot of stuff that was wrong with Pydantic.
Супер. Дякую, В'ячеслав. Дякую всім за активність, за запитання.